question says, name the following compounds. Remember that there are different naming rules for main group ionic compounds with metals that form multiple charges, many transition metals, and metals underneath the nonmetals, and covalent compounds. So we have all of these different compounds, and we need to name them. We also have polyatomic ions, which in the previous question we named, but having that previous question handy, okay, can be useful because those polyatomic ions are going to come up again. So when we're first starting to do this, all right, using something like this can be very helpful. So it's kind of a decision chart, okay? So the first question it asks is, does the compound contain a metal or a polyatomic cation? And the polyatomic cation that it might contain is NH4 plus ammonium, because that's the only polyatomic ion that's positively charged. Ionic compounds must contain both a metal and a non-metal, except if they contain a positively charged NH4 plus and a non-metal, they can still be ionic because they have a plus charge and a minus charge. So if the answer to this is yes, then the compound is ionic if it contains a metal or NH4 plus, which is the only polyatomic cation. If it's no, it's a covalent compound. It's going to be between two or more non-metals. Note that we name ionic compounds and covalent compounds differently. If it's a covalent compound, we basically use the prefixes. So we name the first non-metal and the second non-metal, and we use prefixes to indicate the number of each non-metal. So carbon dioxide, for example, contains carbon and oxygen, which are both non-metals, so we use the prefixes. If it's ionic, the question we want to ask ourselves is the metal capable of forming multiple charges? Generally speaking, this is transition metals, okay, the B group metals, and metals underneath the nonmetals, tin and lead, are the two most common. These compounds, if they're capable of making multiple charges, they're still ionic, but if you say yes, we need to use a Roman numeral to indicate the charge on the metal. If we say no, these are the easiest to name because these are main group ionic compounds, and we just name the metal and the non-metal ending in "ide," which is relatively easy to do. Note that if it has a polyatomic ion, we name the polyatomic ion. We don't use the "ide" suffix. So this is basically how it works. Now, once you have done a bunch of these, you don't really need this anymore, but until then, it can be helpful, may be helpful. So the first thing we have is BaSO4. And the first question is, does the compound contain a metal or polyatomic cation? Note that the metal or NH4 plus will be written first. So the first thing is barium. You may know barium is a metal, but if you're not sure, find it on your periodic table. You find barium right there, and it's a metal. So the first question, the answer is yes. The next thing is the metal capable of forming multiple charges? Or is it main group? Because if it's main group, if it's a main group metal, 1A, 2A, or 3A, it's not capable of forming multiple charges. So the answer here is no. So name the metal, and then name the nonmetal ending in "ide," or the polyatomic anion. So in this case, we have SO4, which you just have to remember is sulfate. So we name the metal barium, and we name the polyatomic anion, which is sulfate, and this is called barium sulfate. Let's look at the next one. ALN. Does the compound contain a metal or polyatomic cation? You probably know that aluminum is a metal, but if not, you find it on the periodic table right there. Now, is the metal capable of forming multiple charges? Well, aluminum is a 3A metal, so it's always plus 3. So this is yes, and this is no. Name the metal, and then the nonmetal ending in "ide." This is aluminum nitride. Next one, SO2. Does the compound contain a metal or a polyatomic cation? Sulfur is a nonmetal. Oxygen is a nonmetal. So here we use prefixes because this is a covalent compound. It doesn't contain a metal or ammonium. So it's a covalent compound. So we name sulfur dioxide. We use the prefixes. So this one is called sulfur dioxide. note that because we have 3 different naming schemes, we haven't gotten to the third one with the Roman numeral yet, but because we have 3 different naming schemes, this is helpful for identifying which naming scheme we should use. Let's look at the next set. Looks like I gotta go up a little bit so I can fit it all on the screen and still write. We have COCl2. Does it contain a metal? Yes, cobalt's a metal. Is cobalt capable of forming multiple charges? The only transition metals that I put on here are all capable of forming multiple charges. So cobalt, yes, it's capable of forming multiple charges. So we have yes and yes. It says name the metal and then name the non-metal ending in "ide" or the polyatomic anion. In this case, it would be just chloride. Use a Roman numeral to indicate the charge on the metal. So we need to find the charge on the metal. A few questions ago, we talked about how to find the charge on the metal, but essentially it is a algebra problem. The charge on cobalt, which I don't know, plus 2 times -1. There are 2 chlorides, each with a -1 charge. How do I know it's -1? Because it's 7A, so therefore it's a -1 charge, equals 0, the overall charge on cobalt something chloride. In this case, in all ionic compounds, they're neutral because they're not polyatomic ions, okay? But you also can know that because there's no charge here. When you do that, you find that this is cobalt is equal to +2. So basically 2 times -1 is -2, then add 2 to both sides, you find that cobalt's +2. So the name of this thing is cobalt, Roman numeral 2, chloride. Notice that cobalt has the Roman numeral 2 because it's a transition metal here, versus barium and aluminum do not have Roman numerals because they're in A groups, they're main group. So use Roman numerals if it can form multiple charges. Don't use Roman numerals if it can't. Different naming schemes, that's why this might be useful for you. All right, we have SR with PO4. Again, having the previous question is useful. That's why they're in that order, so you can look up there and see that this is phosphate. Okay, so we need to find the metal. Okay, this does contain a metal, and we need to find it. Strontium, it's right there. It's main group, so therefore we do not need the Roman numeral. So we can call this strontium phosphate. No Roman numeral because strontium is main group. All right, we have NH4Cl. This is interesting because this is an ionic compound that doesn't contain a metal. So the first question is, does the compound contain a metal or a polyatomic cation? And the polyatomic cation is ammonium. Okay, so it has ammonium in it. Ammonium is not capable of forming multiple charges, so you're never going to use the Roman numeral with ammonium. So this is just ammonium chloride. Let's look at the next group. All right, we've got P2O5. Does the compound contain a metal or a polyatomic cation? It certainly doesn't contain ammonium. Is phosphorus a metal? If you're not sure, find it on your periodic table. It's right there. So this is a covalent compound because it doesn't contain a metal or ammonium. So here we're going to use the prefixes. This is diphosphorus, pent oxide. Technically speaking, you don't want to put pentaoxide. It's pentoxide, but that's not a big deal. Okay. We have SnSO42. Does the compound contain a metal? Well, Sn is tin. If you're not sure, just find it. This periodic table has the names, if you can see it, along with the symbols. So Sn is right here. Is a metal capable of forming multiple charges? It's underneath these nonmetals. So tin is actually capable of forming multiple charges. Said another way, we need to use the Roman numeral. Use the Roman numeral to indicate the charges because we have yes, yes. So let's look at this. Sn, which is X, remember to find the charge, we have to do algebra, plus 2 times -2 equals 0. What does this mean? It means the charge on tin, that's what I don't know, that's my X, plus 2 times the charge on sulfate, there's 2 sulfates, each sulfate is negatively 2 charged, equals 0, the overall charge on tin sulfate, tin whatever sulfate, okay, like so. When we do that, we have Sn minus 4 equals 0, and then Sn equals plus 4. So the name of this compound is actually tin. Roman numeral 4 is IV, sulfate. Okay, we use the Roman numeral because tin is underneath the nonmetals, so therefore it can form multiple charges. NCl3. NCl3, does it contain a metal? No, nitrogen is not a metal, and Cl is not a metal. And metal is usually written first. In fact, it's always written first in these examples. Okay, so what are we going to do with this one? We're going to use the prefixes. This is nitrogen, trichloride, like that. All right, last one on this group. And naming takes practice. So this group is probably not enough. You got to practice with the names of these things because it can really cost you on an exam, for example, if you don't know the formula of the thing you're looking for. So if it says what's the theoretical yield of this compound in words, okay, you have to know what this is in order to be able to answer that question. So we have FeOH2. Does the compound contain a metal? Well, Fe is iron, which is right here. Okay, and we have OH2. So iron is ionic, right, because it contains a metal. Iron is also a transition metal, so it's capable of forming multiple charges. Again, not all transition metals are capable of forming multiple charges, but the only ones that I put on this table are. All right, so that's basically how this is going to go. So we need to find the charge on iron. We need to remember, and it's in the previous question, that hydroxide is -1. So we have Fe, that's what we're looking for, plus 2 times -1 equals 0. And when you do that, you find that Fe equals plus 2. This should be called iron, Roman numeral 2, hydroxide. So again, make sure you're practicing this stuff because there's 3 different naming schemes, and if you see here, these are all randomly distributed among those 3 naming schemes. You can't go ahead and call this iron dihydroxide, and you can't call it iron hydroxide. You can't call this barium 2 sulfate, okay? And you can't call this cobalt dichloride. So you have to use the proper naming scheme to name the proper thing.